Good morning to everybody. I'm Kaushik, speaking from QCrete Readymix Concrete Private Limited on this webinar, which is about our experiences with Flyash. This is incidentally webinar number 15 in our series of webinars, which we have designed to build some awareness and bring in some experience from different speakers. The current topic of our experiences with Flyash, what I'm trying to do is I'm having three sections in this. One is some general information on Flyash, and then some of our experiences, what we had in the last 20 years or so on usage of Flyash. And also I will speak in the third section about some points we should take care while using Flyash. We from QCrete Readymix appreciate your time having come on a Saturday morning to listen to us. Thank you all. Flyash, as you are all aware, is a pozzolanic material. It is called pozzolanic material because it was first found in a village called Pozzoli in Italy. These pozzolanic materials, they don't themselves can make directly strong concrete. They act in presence of water and another activator like OPC, and then you will get a strong concrete or whatever hardened concrete you can call it as. So Romans started using long back 2000 years ago. A lot of history is there. A lot of structures have been built using volcanic ash by Romans and other people across the globe. And Flyash, I can say before start of this journey into this particular webinar, that you can say it is a godsend material. We could not have made a lot of concretes which is having a lot of these benefits without the use, as we say, without the use of such a wonderful material which we are going to speak now. Flyash comes from thermal power plant. When the coal is burned, some of the particles will fly after being the coal is pulverized and burnt in the thermal power station, and these particles which fly away are collected in through electrostatic precipitators, and they are packed and sent to either cement companies or ready mix companies. Larger particles settle down at bottom and they are called as bottom ash, and these bottom ash generally are coarser. Flyash generally is earlier dumped into sea, made into slurry form and dumped outside the thermal power plants. You can see in and around many of these thermal power stations Flyash lagoons. And earlier, say about 20 to 25 years back, the Flyash was not used as it is being used now, and it was spread all over for several kilometers away from the thermal power plant, and it was causing havoc on the nearby environment. Now things have changed. Things have changed a lot because a lot of uses of Flyash have been found. Now, the beauty of Flyash, if we look at electron microscope, the particles are spherical in shape, and this gives a very good workability in concrete and the ball bearing effect. like the spherical shaped particles move over each other and give lubricity to the concrete mix, and pumpability and all will be increased. So the sphericity of these particles make a big difference when we are using fly ash as an SCM. So before we move into our experience, as I said, we are going to talk for some time on different grades of fly ash, kinds of fly ash, and some of the benefits that we get from fly ash. So as a part of that, we are talking about grade 1 and grade 2 fly ashes as per our code IS 3812. Grade 1 is where the glass content or SiO2 plus Al2O3 plus F2O3 greater than 70%. Grade 2 is comes from lignite coal, and it is having a SiO2, Al2O3, Fe2O3 greater than 50%. We need to remember this SiO2, Al2O3 plus F2O3 is the major component, and this is the active component which makes this SCM very popular. Whereas we have other classifications from ASTM where it is classified as Class C and Class F. Class C is where the CaO content is higher, and it comes from subbituminous coals. And Class F, it comes from Class F is where the CaO content is lesser than 10%, and it comes from bituminous coal, combustion of bituminous coals. Predominantly in India, most of the thermal power plants are using this kind of coal, and hence we get more of type F fly ash. Type C fly ash is not abundant in India. And so a lot of work has been done in India on Class F fly ash or type F fly ash. There is also another one called Class N fly ash, which is N stands for natural, which is as per ASTM C618. So BS 8500 has other type of other categories where they have classified fly ash based on loss of ignition. Loss on ignition is an important property where the loss on ignition determines how much superplastic or admixture is required, and it also, this LOI also affects the air entrainment properties. Air entrainment properties of concrete. So there are several classifications. Okay, of course, we are talking about in what we are doing in India, but we need to be aware that several other classifications are around, and we need to be aware that that LOI should not cross 5% as per IS 3812 in India. When we are talking about SCMs, we need to think about how it reacts with cement plus water, whether it is pozzolanic or hydraulic. Hydraulic means it reacts with water easily, and here you can see the when the fly ash is having high CaO, some of the fly ashes may have a CaO content of 20%, 30%, things like that. So in that case, it will move into hydraulic. It will become hydraulic in nature, and you can see GGBS also is comparable, and it is going into hydraulic region, whereas other materials which are predominantly having SiO2, Al2O3 plus Fe2O3 come into classification under pozzolanic section. So we need to know that when these materials are more towards pozzolanic, they don't directly react, and they have a high shelf life, and they are not affected by moisture. Even if we put some amount of water into this, it will not become hard, and they will react only in presence of cement or other kind of any activator. Typical physical properties which we need to mention, because most of the users may be using and they may be checking all these properties, but just I want to talk about the minimum requirements. We need to see here the requirements as per IS 3812 is 320 meter square per kg. That is the minimum fineness that we need to have. And another most important factor which I need to draw your attention is residue on 45 microns. As per IS 3812 should not cross 34%. So any fly ash which comes to a plant which is having a retention of more than 34% on 45 microns stands to be rejected. So we have already talked about the LOI, we have talked about SiO2, L2O3, Fe2O3 requirement. So what does it happen actually when we are talking about reaction between fly ash and water? When ordinary Portland cement reacts with water, you get CSH plus calcium hydroxide. CSH is a strong link. It is responsible for strength of hardened concrete. The other one, COH twice, short named as CH, is a weak link. That is the one which gets attacked actually. You have sulfates and you have other materials, carbon dioxide, all the other agencies, external agencies tend to act with calcium hydroxide and make the concrete weaker over a period of time. So the deterioration of concrete is dependent on how much amount of free amount of calcium hydroxide is available in the body of concrete. So when we reduce the usage of OPC, you have a reduction in calcium hydroxide, and to reduce calcium hydroxide and to make calcium hydroxide react with another material to make a more stable CSH gel and more amount of CSH gel and lesser amount of calcium hydroxide, you need a combination of SiO2, and that SiO2 is fed from these pozzolanic materials like fly ash. So Portland cement reaction, cement plus water, CSH plus CH, pozzolanic reaction, CH plus pozzolane plus water. It will lead to more CSH gel, more denser concrete, more stronger concrete, and of course you will be left with some amount of calcium hydroxide. So here we are talking about this pozzolanic fly ash. So this reaction is also called as secondary hydration. The initial hydration is between cement and water, giving rise to calcium silicate hydrate gel and calcium hydroxide. The secondary reaction is the SiO2 of fly ash reacts with calcium hydroxide, consumes calcium hydroxide, forms more calcium silicate hydrate gel and some amount of calcium hydroxide. The amount of calcium hydroxide is reduced, denser concrete is made. So we talked about the sphericity of fly ash particles. Because of the spherical nature of these fly ash particles, you get improved workability. This is one of the biggest advantages that we get while using fly ash. When you are using fly ash concrete, anybody who has done concrete with fly ash and without fly ash, he can easily appreciate that the fly ash concrete has lesser segregation, lesser amount of bleeding. So the benefits as we can list is it reduces bleeding, increases pumpability, which is very good for a concrete producer. And another one advantage for a concrete producer is it reduces equipment wear and tear. The advantage to the customer when you are buying a fly ash concrete is long-term strengths are increased, reduced drilling shrinkage, reduced permeability. So as a result of secondary hydration, you have more stable microstructure, denser microstructure, and you are also reducing the water cement ratio in the body of concrete when you are using fly ash. and hence the permeability is reduced significantly. This is one of the pictures which shows that as we are reducing the OPC content, as we are replacing OPC content with certain amount of fly ash, the water content goes on reducing actually. Water content goes on reducing. This is one of the pictures. Okay, so it is said that every, like say for example, if you are typically reducing about 25% of OPC by fly ash, I mean to say you are replacing in a mix about 25% through fly ash, you can get a water reduction of about 8 to 10%. Another picture which talks about reduced water content, where reference concrete water has been given, and when we are talking about as the loss on ignition, you can see when the loss of ignition increases, water demand increases. That is the reason all the codes across the world give some stipulation on LOI. And as we discussed earlier, LOI also affects the air entrainment and things like that. One of the major effects when we are using fly ash on concrete is reduction in temperature. You can see this graph where the fly ash concrete has a lower buildup of temperature, and control concrete has a higher temperature buildup, which can cause thermal stresses. So use of fly ash can help in mass concreting like raft foundation, things like that. So like the other SCM like GGBS, fly ash also has a significant benefit in terms of reduction of temperature, especially beneficial to the thick structures like raft foundations. Again, another one picture which talks about the hydration level being reduced by usage of fly ash. And here you can see as the CO content increases, that is if we are moving from class F fly ash to class C fly ash, if the CO content increases, the heat of hydration increases. Here we have another graph which talks about compressive strength versus age. Here the control graph, you can see the control graph as the age is moving higher and higher as the concrete is aging, the graph flattens actually. So the graph becomes parallel to the x-axis. Whereas when we are talking about fly ash, initially the strength gains are lower and there will be strength buildup over a period of time. So this graph is a representation of that one. So if we are increasing, as we increase the percentage of fly ash, the long-term strengths are going up and up, as we can see in this graph. So permeability reduction is another very, very important advantage by using fly ash. And you can see here the chloride resistance, which is tested as per ASTM C1202, is significantly reduced at the same water cement ratio as we are increasing the fly ash content. As we increase the fly ash content, the RCPT value has reduced significantly, pushing the concrete to a very significant higher levels of durability. So RCPT value reduction is one of the major contributions fly ash can do on when it is incorporated into concrete actually. So worldwide, fly ash is a accepted material for reducing the chloride content or resistance to chlorides. Another graph which talks about how the chlorine penetration has been affected by usage of different percentages of fly ash, and we can see the control concrete with 0% fly ash on top, telling that the penetration is highest there. So we are trying to tabulate how the properties are affected. In fresh concrete, workability is increased as the water demand is reduced. Setting time is extended. Especially, we need to be careful in winter times. Chemical admixtures may cause rapid or severely retarded set at certain temperatures. So in such case, we have to consider either we have to reduce the fly ash during cold weather, and also we need to be careful which admixture we are trying to use. Heat of hydration, it is reduced when you are using glass of fly ash. Classy fly ashes have to be used at higher levels of replacement, say more than 50%. Early age strength, since the entire reaction takes place in kind of two stages. One is cement plus water forming CSH gel and calcium hydroxide. Second, the SiO2 and other components of fly ash reacting with the hydrated products like calcium hydroxide, consuming calcium hydroxide, forming some more CSH gel. So there is a time lag, and hence early ages are affected, reduced, especially at 1 day. So we need to be taking care of this one actually. Long-term trends are increased. So in many countries, other countries, they have started specifying 56 days and 90 days trends actually. Permeability reduced significantly, especially at later stages. So RCPT value, which is a very, very important quality parameter, especially in coastal areas, especially in marine structures, increases as at later ages, and hence it has a significant effect and benefit. Alkali silica reaction is reduced. Sulfate resistance is increased significantly. One of the problems some people quote and some researchers quote is resistance to carbonation is decreased when we are using fly ash, but it can be countered by using by using concrete at definite dosages, required dosages of fly ash addition. Also, we need to cure the concrete properly. If we don't cure properly fly ash concrete, and if we don't provide a proper cover to concrete made with fly ash, we will have problems which can be detrimental, especially from the point of view of carbonation. So we need to be careful about carbonation effect. So for that, we need increased curing when we are talking about fly ash incorporated concretes vis-a-vis OPC mix. And cover also has to be increased actually when we are talking about fly ash incorporated concretes. So resistance to salt scaling is decreased. It can be countered. We need to reduce the water cement ratio, and we need to design the concrete properly, and has to be finished. The concrete has to be finished properly. As we already discussed, one of the points which we highlighted is resistance to sulfates are improved. The vulnerable concrete component is reduced, COH2 is reduced. Like you can see here, a 20% fly ash addition and 40% fly addition has performed significantly well against a general purpose cement or a normal cement, concrete actually. So concrete is protected against sulfates when we are using this Flyash. We already discussed impermeability of concrete is improved. One of the most important points, like in any concrete production unit, the most important thing for a producer and user is what happens to the strength of concrete 28 days and later. So when a customer is purchasing concrete with Flyash, you can be sure that the strength of concrete increases significantly after 28 days. And this is a very important benefit to a buyer who is buying a Flyash concrete actually. Long-term strengths are improved, particularly post 28 days. This is another slide which talks about the resistance to chloridans. You can see OPC at 44.7, and then with 70% OPC, 30% Flyash. So this is a significant contribution, as we are talking about already. The RCPT values or resistance to chlorides is enhanced using Flyash. Now, the most important point, other than these benefits, the environmental benefits of Flyash in particular and SCMs in general is the most important point which has made usage of Flyash throughout the world popular. When we are manufacturing cement, it is made by mixing calcium carbonate and silica. These are dried using waste heat from kiln. They are then underground into fine powder, heated up to about 1450 degrees, then ground into fine powder. It is a very energy intensive process. The total amount of carbon dioxide produced is about said to be about 0.9 tons earlier. About for every 1 ton of production of OPC, it is said that about 0.9 tons of carbon dioxide is produced. Now, embodied carbon dioxide from the point of production until the product is made actually in a factory. Different combinations, how the different combinations work against the benchmark of about 900 kg per ton, 900 kgs of carbon dioxide per ton. That is the benchmark. That is ordinary Portland cement, otherwise SEM1. Here you can see in this table, when we are adding OPC, there is about 900 kg per cubic meter of carbon dioxide, embodied carbon dioxide. When we are talking about Flyash addition between 21 to 35%, the embodied carbon dioxide is around 722 and 735 when we are talking about GGBS. So what the table is talking about is, if you want to have a really significant reduction in carbon dioxide, then you need to probably move to about 36 to 65% of either GGBS or Flyash. For example, at the last you can see when you are adding about 36 to 55% of Flyash, you have a reduction, you have a carbon dioxide production per ton of entire concrete, the mix is about 586 to 413 kg per cubic meter, which is comparable with the 36 to 65% of GGBS. So we are not really comparing the two products, but here Flyash and GGBS are almost on the same scale with a small difference actually when we are talking about reductions in the range of 36 to 65% actually. So this is a significant contribution by SCMs, especially you can see Flyash. There are other ways of comparing the environmental impacts actually. Here, the research people, DRE, Environmental Profile Scheme, has produced numerous profiles where some of which are made freely available. Some of these profiles are kept confidential by the supplying industry, the manufacturers, cement, Flyash and GGBS manufacturers. However, both secondary cementitious additions like Flyash and GGBS have made public the environmental profile. Each profile has a value of global warming potential over 100 years, expressed as equivalent tons of carbon dioxide. Each combination here, when you are talking about any combination, OPC plus Flyash or OPC plus GGBS, whatever it is, it has a particular global warming potential over 100 years. Okay, so that has been given in this table, which is very important actually. Let us say we are doing let us take in this table a precast concrete mix. Okay, here if you do with OPC mix, if we are doing this with OPC mix or cement, it is called as SEM1 cement or type 1 cement in US. Here you have 426 kg per meter cube carbon dioxide equivalent, which is the global warming potential over 100 years. Whereas if you are moving towards 50% Flyash or 50% GGBS, it is almost reduced by 38 to 40%. There is a reduction of global warming potential over 100 years by 38% to 40% when we are talking about usage of Flyash 50% and GGBS 50%. Even when you are using 30% of Flyash, the reduction is about 20 to 30% on various types of concrete. So this is a very, very important table actually, which talks about the environmental impact. And we can see that we need to try to use as much Flyash as possible based on this table. So why we should specify Flyash actually? So Briand Mathur in 1982 told that we should be moving from a position of asking why we should use Flyash in concrete to a position of why we should not use Flyash. And he also told in 1982, Briand Mathur in US, that OPC mixes will be found only in museum. Okay, we have made a significant progress in use of SCMs, but still some people are hesitant actually. So some of these specifications tell us that if you want to improve sulfate resistance, if you want to improve chlorine resistance, if you want to improve long-term strengths, if you want to improve chemical resistance, if you want to improve protection of reinforcing from corrosion, if you want to improve concrete finish, if you want to improve abrasion resistance, if you want to improve on temperature reduction, if you want to improve what you are contributing to environment, if you want to reduce the carbon footprint, if you want to reduce concrete permeability, use Flyash. That is what some of the specifications are talking about throughout the world. So as responsible engineers, we should be completely moving from the position of not using Flyash to the position of completely accepting this, because the point is today we have tons and tons of literature available and a lot of experience, a lot of material has been used in many structures, and from many years. For last 4 5 decades, a lot of structures have been built using fly ash. We also have not only smaller amounts of fly ash, there are concretes made with high amounts of fly ash, which is also called as high volume fly ash concrete. Many benefits are there when you are using high volume fly ash concrete. It has improved workability, reduced bleeding, heat of adhesion is reduced, permeability is increased, higher ultimate strengths, increased durability, lower carbon dioxide emissions, which we already talked about, and very good sustainability. So high volume fly ash concrete has already been there. A lot of structures have been built. There are numerous examples. It is not new, actually, as I've been talking about. In the UK, a series of trials using HVFA, then called HFCC, high amount of fly ash cement concrete, took place in Didcot Power Station, slipways of Mumbles, Grangtown Link, Wincanton Sewage Works, etc. These were subjected to series of tests after 10 years of service, including compressive strength, depth of carbonation, permeability, and chloride and sulfate penetration profile. The researchers concluded that HFCC could be used in structural concrete applications exposed to sulfate and chloride attacks. Some 30 years on, these concretes are still there and performing very well. This is very important statement. After 30 years, the concretes are there doing its duty. So we need not have to bother about high volume fly ash concrete durability aspect. There are a lot of reports where Mr. Malhotra, one of the great concrete technologists, have done a lot of work. The concretes used span a wide range of applications: 50 MPa columns, piles, shotcrete slabs, etc., covering full range of structural limits. We have examples. We have the Hindu temple in Kauai Island, Hawaii, where massive structural slab, 57% fly ash has been done, with the peak temperature of 40 degrees being recorded, producing in homogeneous crack-free microstructure concrete being reported. So we can see Didcot Power Station in 1981 when they used high volume fly ash concrete, and this temple with about 57% fly ash. The slab is made with 57% fly ash. And another Hindu temple in Chicago, built with high volume fly ash, 65% fly ash concrete for reinforced founded beams and shear walls to achieve 1,000-year service life. So it is, somebody is thinking of 1,000-year service life, and somebody has incorporated 65% fly ash. Okay, in these structures, they have specified long-term strengths. So it is not new, actually. High volume fly ash concrete has been tried and it's successfully used, actually. So many of the works have been done in India also, where they have developed SCC with different combinations. We can see these mixes here, where you have SCC concretes, different SCC concretes made with combinations of good amount of fly ash, high amount of fly ash. And one of the mixes you can see is where they have removed the crushed sand and used fly ash as a filler material. And you can see the water to cementitious ratio. They have put water to binder ratio as 0.15 actually. And you have got the free flow concrete, and you have got a very high strength, 28-day strength of 62.2. So these are some of the applications done in India actually, where they have used high amount of fly ashes actually. So somebody talking about fly ash and hesitant to use fly ash, I request them to think about how they have built Burj Khalifa, the tallest structure in the world. In case of Burj Khalifa, the fine aggregate percentage for tower mixes was approximately 50%, and fly ash was used at a replacement level of 13 to 20%, together with microsilica 5 to 10%. C80, C60, that is M60 and M80 have been done. The tallest building in the world, they have incorporated fly ash. So I don't think we have to be bothered about any other thing actually. So for this tallest building, you can see a raft mix where the cement is used at about 252 kgs, fly ash 168, silica fume 30 kgs, water cement ratio 0.32, the concrete strength was about grade of M50, other grade M80, OPC 380, fly ash 60 kgs, silica fume 44 kgs, and a water cement ratio 0.27. And the water cement ratio has been achieved by using a very strong PC based, specially made PC based admixture actually. State of the art PC based admixture, which has given a huge amount of water reduction. And I think we don't need any other testimony other than this for usage of fly ash actually. The tallest building on the planet is standing with the usage of fly ash, and I can say this puts to an end the application of fly ash. Any haters of fly ash or any people, any person who has any kind of inhibition in using fly ash, the tallest building in the world has been built using fly ash. So we are surprised to see that high volume fly ash can be used in pre-blended cements. Some countries in Europe, they're blending in different ways, different proportions, and making fly ash based cement actually. High fly ash amounts are used actually. This one, you can blend it in cement, you can blend with concrete, and then you can also use it as a filler actually. Like say for example, a specification like for example IS 3812 says we have to use 15 to 35%. You can use extra amount of fly ash in terms of as a filler, as a replacement for sand if you don't have a good sand, and we can reduce the water cement ratio and make good concrete actually. So fly ash can be used as a filler material instead of sand. So this table is very interesting actually. You have from BS specifications, you have different kinds of cement, types of cement, where a pozzolanic cement can have between 36 to 55%. A composite cement can have a fly ash content of about 31 to 50%. So different combinations have been given, different choices have been given to the customer. So what I'm trying to talk about is that you have choice to make use of fly ash, and there is classification available in other countries. Especially, I'm surprised that in cold countries where the reaction between cement and fly ash is slower, much slower when compared to country like in India or any tropical country, this amount of fly ash is being allowed to be used actually. Yeah. And high volume fly ash concrete, they are permitting whatever is between 55 to 85% for various applications. So some of the high volume fly ash concretes, mixed proportions guidelines have been given here, where you can have a M40 concrete with a very good amount of fly ash, lower amount of OPC mix actually. So all this is possible if the structural engineer or specifiers start using from different perspective. The strengths can be specified at 56 degrees or 56 days or 90 days actually. And the benchmarking of 28 days should be kept in the background. Benchmarking should be done on 56 or 90 days. Anyway, any building, whether it is India or abroad, most of the buildings, most of the residential projects, most of the commercial projects also generally are occupied after 1 year or 2 years actually. So Nowadays, you can see the occupancy level is very, very low actually, and you have a lot of inventory of flats and things like that. So why can't we consider specification of concretes at later ages actually? So you can, well, if you can do that, then you can limit the usage of OPC and can use such specifications depicted in this table. So what are the characters? We have been talking, we have been repeating about the usage and the benefits actually. Improved flowability, pumpability, compactability leading to smoother surface finish. Total amount of bleeding water is low or negligible in case of high volume fly ash concrete. Setting time of HVFA concrete in general is longer than the conventional concrete made using Portland cement alone. This is due to the low cement content, the slower reaction process of fly ash, and higher dosage of superplastizer is required. Due to low cement content, autogeneous temperature rise in high volume fly ash concrete is rather low. So these are the characteristics of HVFAC. As we already discussed, need to adequate curing is very, very crucial for HVFA. As we told already that the carbonation has to be taken care. The carbonation will be of an important factor. We need to cure it properly, and we need to reduce the water cement ratio to very, very lower level to have all the benefits from HVFA. Good dimensional stability, resistance to cracking from autogeneous shrinkage, drying shrinkage. However, in unprotected concrete, there is higher tendency for plastic shrinkage cracks. We need to be anything we are doing with SCM, including fly ash or even GGBS for that matter. We need to consider the initial curing is important. When we are doing concrete on field, actually, either temperature can go up or wind velocity go up very high, or humidity can become low, water can start escaping, then it leads to cracks actually, plastic shrinkage cracks. So no need to panic actually, no need to panic. These are non-structural cracks. We need to understand that when we are getting so many benefits from SCMs like fly ash in this case, we need to be mindful of the fact that we need to do the basics right actually. Curing in the early ages, as soon as the concrete is placed, within 1.5 to 2 hours, depending upon the temperature and wind velocity, we need to protect the concrete. Start early curing, and 1 day curing and curing continuously is very, very important. Okay, so if we don't do this, we will lose the benefits which we are talking about actually. It is very, very, very important that we protect the concrete and treat it in a proper way. And as we discussed earlier, the curing time should be slightly longer when we are talking about this fly ash concrete. Very high durability in terms of reinforcement corrosion. ASR, sulfate attack is reduced. Superior environmental advantages due to ecological utilization of large quantities of fly ash. Reduced CO2 emissions and enhancement of resource productivity of the concrete construction industry. So as we said, it is a godsend particle, I can say. Fly ash is a extremely beautiful product which can be harnessed. The potentials can be harnessed for the use in construction or concrete industry. So we are coming to talk about what we did with fly ash in 1999. We started to have trials actually in Chennai, where at that point of time, the commercial ready-mix companies were hesitant to use, customers were hesitant to use fly ash, and they were thinking that by adding fly ash, we are doing something wrong. Some of our friends in the industry even started spreading messages that this particular company where I was working, they're selling cheap concrete using fly ash. They're using fly ash. And on the other hand, they were trying to secretly add fly ash actually. They were adding fly ash secretly. and we wanted to promote Flyash openly, and we wanted to print OPC PFA on our invoices. Actually, all the invoices when we are doing OPC Flyash concrete, we are printing it and telling to the customer. We are bringing the customers to our lab, showing them the trials that we have done, showing them the long-term trends that we have seen. Uh, More than about 1,500 trials were done from fly ashes collected from Ennore Thermal Power Plant, Chennai, Mettur, Tuticorin, and at that time we had um, there were two Britishers. One was both of them were eventually sorry. I was reporting to them. One Marcus Ravensburger and one Peter Rhodes. They were continuously telling that the fly ashes in India are highly inconsistent, and we cannot produce good quality concrete with this. So my point was, with the inconsistency that is there, that is always there with this kind of fly ashes, we can make sufficiently adequate concrete, uh, which can meet all the requirements as per IS 456, all the requirements of customer. We can make tailor-made concretes using fly ash. This was our effort actually, and ultimately after about 1,500 to 1,800 trials, we could convince and started production of OPC plus fly ash mixes actually. And some of the structures built about 20 years back um, in Chennai, incorporating fly ash. We can see we used for this M20, 25 and M30 with PFA. Another important structure in Chennai. This was actually initially they planned it as a hotel and then they converted it into software park, where from foundation to the top slab 20 years back, all the concretes were done with OPC plus fly ash. Another important structure was Infosys, where all the concretes uh, were done with OPC fly ash. This is Infosys campus in Mysore. So in the recent times, we did from QCrete, we had these structures in Cochin, where for this structure we used 285 plus 65 concrete grade M25. SRM builders we used 370 OPC plus 80 kg of fly ash M35. Samson Jacob we used 248 OPC 62 fly ash, and then ANG Associates 260 plus 100. The fly ashes were from Mettur and Tuticorin. In Infosys, the mix was for a PT slab actually. So they specified a 7-day strength of 28 MPa. And generally we used to get about 7 days of 33 MPa and 28 days 44 MPa. So here what we need to see here is with OPC plus fly ash, we can get adequate 7-day strengths also, even though traditionally OPC fly ash mixes are slower in gaining strengths up to 7 days. We can design the mix, controlling the water cement ratio with good admixtures, where we can get 7-day strength required for a PT slab. The only important point here is if we don't get this info, some customers are there who don't talk about the 7-day strength. Then they will say we need to we have used this for PT slab. Then it will be a problem actually. So if we don't get information, we cannot make concrete as per requirements. So if we get the requirements from customers, we can make proper concrete with fly ash, and tailor-made concrete we can give. So this was a Pentecostal church in Chennai long back, and here it is a classical case where we cast the cubes on site actually, and you can see a 240 plus 100 kg mix, 240 OPC, 100 kg fly ash. Um, we had a 28 day strength of about 37-38 MPa, and in 365 days it jumped from 38 to 55, which is the fly ash is from Ennore thermal power plant class F fly ash. Again, another case where we had this 28 day strength of about 38.34 and 150 days about 57 actually. So what we are talking about here is there is a significant jump between 28 days later on, and of course this depends upon the fineness of fly ash and the reactivity of fly ash. Also it depends upon the type of cement and fineness of cement and several other properties of the combination. But one can be assured of the fact that whenever we are using OPC plus fly ash mixes, you are getting a very good strength at the end, especially after 28 days. So we used the property pumpability to pump the concrete. We made a M10 mix where the concrete had to be pumped for M10 concrete for a PCC for a particular customer in Chennai, where the OPC mix was 130 and fly ash mix was 155 kg, and the you can see the strengths actually. So whenever we used to have long horizontal pumping or higher vertical pumping, we used to use fly ash as a pumping aid actually. So the cohesivity, the pumpability of the mix was completely increased by usage of fly ash. So we also tried for a customer OPC fly ash mix for high grade concrete, because the customer had come up with the hesitation and telling that no, you cannot get a M60 concrete by using fly ash. So we took it as a challenge. We made trials and we supplied about 30 to 40 cubic meter of this concrete way back in around 2008, 2009 actually, for a particular customer in Hyderabad. So here we can see the concrete has a OPC content of 450 kgs, and OPC plus fly ash is about 120 kgs. So total water cement ratio, free water cement ratio is about 0.31. You can see the 28 day strength of about 77 MPa. So almost M65 or M70 is achieved by using a proper PC based admixture. So this is another slide where the slide shows significant improvement between 28 days to 90 days. We can see a jump of almost 40% between 28 days to 90 days. The fly ash basically was from some of the fly ash is from Mettur and some fly ash came from Tuticorin. So results are based, this curve is based on more than about 600 results actually. Each result is 3 cubes actually. So in we did this in Coimbatore, and you can see a 40% jump between 28 days to 90 days. So this is a huge benefit to the customer actually. So a customer buying concrete can have 20 to 40% jump between 28 days to 90 days. So some of the, we also did some trials towards high volume fly ash concrete, where we used 165 plus 205 for attempting to make M30 concrete actually. So you can see at a water cement ratio of about 0.4 with a PC based admixture, we had proper slump, and then the 28 day strengths were okay, acceptable actually. You cannot exactly be happy as a M30 concrete, but okay, you have come very close to M30 concrete. And as I said earlier, the specifiers, if they can move from starting to specify literage strengths, this will be a big jump in terms of shifting the technology from 28 days to literages actually, and we can consider these kind of mixes. So having gone through the benefits, having gone through some of the examples, some of the experiences that we have got. So what mistakes happen actually? What mistakes we do when we are talking about fly ash concrete? When we are doing fly ash concrete, let's say we are having a 320 kg OPC mix. We cannot take a 320 kg mix and directly replace with fly ash to get the same strength. If you want to get a same strength actually, let us say you are using 320 kgs, you want to get same strength of 320 kg OPC, you need to increase the total cementitious. Total cementitious you need to increase. On the other hand, if you want to, you don't want that much strength, which is given by 320 kg OPC, then in 28 days or early stages, then you can just replace by 10%, 20%, 25%, whatever it is. So we should remove the concept that if the 320 kg OPC mix is not equal to 320 kg OPC plus fly ash mix, okay, at the same water cement ratio. If you significantly are able to reduce the water cement ratio in the 320 kg OPC plus fly ash mix, then you can hope to get a better strength in terms of OPC fly ash mix. So this particular thing you need to remember actually, as we already know that when we are using about 25% of fly ash, it gives a water reduction of 8%. So by using a PC based admixture, you can still reduce the water cement ratio further down when you are comparing at the same cementitious content. And we should always reduce the water cement ratio as much as possible when we are shifting from OPC mix to OPC PFA mix. So that is the most important point actually. We need to also remember that 1 kg of OPC in terms of strength contribution is greater than 1 kg of fly ash. So 1 kg of fly ash will not give similar strength contribution in a concrete mix when compared to 1 kg OPC mix. So we need to be aware of that one. So most important point, as I said, when you are using OPC fly ash mixes or any SCM for that matter, we need to reduce the water cement ratio as much as possible to make it a candidate for making higher strength actually. If you want to make a higher strength or equal strength, you need to use the potential of water reduction. You need to reduce the water cement ratio as much as possible. Fly ash, the big problem against which is also a problem which the other SCM people talk about fly ash. And the problem associated with fly ash is it is picked up from thermal power plants. No processing except 1 or 2 companies in India. Nobody else is processing. There are people classified fly ash, but very minimum number of manufacturers are there who are trying to classify the fly ash, make the fly ash finer and sell the product. But most of the fly ashes are just picked up from thermal power plant as it is and sold to cement companies and ready-mix companies and pavers, black manufacturers, etc. So if we don't check the quality of fly ash, the simple test what is prescribed in IS 3812 is 45 microns test actually. If the fly ash has coarser particles, if the particle size is very high, then the reactivity reduces actually. So the fly ash particles will be sitting like dummy particles, just like sand inside the body of concrete actually. So the coarser the particles of fly ash, they will be inert, more inert. They will not participate in the secondary hydration or pozzolanic reaction as we discussed earlier. They will be sitting as dummy particles without much contribution to the strength of the concrete. And in this way, you will not get the expected strength gain actually. It is said that the ideal particle size for fly ash to be very active is said to be between 10 to 30 or 35 microns actually. So if the retention is too high on 45 microns, then it becomes problematic for the concrete actually. In other countries like Europe, all these are specified. All the fly ash characteristics are guaranteed by the customer. For example, we have in the case of European specifications, some European specifications where they talk about different classes of fly ash. Category N, where the retention is less than 40% on 45 microns, and there is another category S, where the retention is less than or equal to 12% on 45 microns. Category S comes with guaranteed water reduction. So if a company is manufacturing or selling a fly ash which is having less than or equal to 12% retention on 45 microns, it comes with guaranteed water reduction. So a manufacturer also guarantees the density should not deviate plus or minus 200 kg per cubic meter. These are some of the specifications I took from BSEN 4501. So here, the manufacturer or the seller or the transporter of fly ash is guaranteeing some of the characteristics or the properties of fly ash, and you can blindly use such fly ashes actually. But unfortunately in India, many of the manufacturers, transporters simply transport the fly ash from thermal power plant to a cement company or ready-mix company, and it is left to these users to take care of the quality, and there is no guarantee from the manufacturer. So that has been one of the you can say objections or one of the points put against the usage of fly ash. I believe in the coming days, in the coming years, these guarantees will come through different manufacturers. We need to be also careful when we are using fly ash admixture dosage actually, and compatibility of admixture. Nowadays it is fancy actually. You know, anybody who talks about concrete will be talking about admixture and cement compatibility actually. So it is very easy to talk about compatibility of cement with admixture compatibility. Okay, so a lot of variations can happen in cement and of course definitely fly ash properties. So we need to be taking care of the dosage of admixture actually. So here a selection of a good admixture with a good water reducing property, plus it should not retard too much actually, because already there is a delay in setting time caused by the slower reaction of fly ash. So you cannot have a high retarding version of an admixture which can again delay the setting time of concrete. You cannot have such kind of admixtures to be incorporated. So this is very important point which you need to consider when you are using fly ash. And expecting concrete to set normally. So you have, when you are purchasing OPC plus fly ash, for example, if you have put this into columns or any beams or slabs or something like that, okay, it will set, it will harden, but the rate of gain of strength in the initial times are lesser, as we have already discussed actually. So you cannot just like that de-shutter this concrete. You need to have some patience. You need to have some patience. You need to show some patience as a customer because you are getting a package of benefits. Increased pumpability, water reduction, long-term strengths, durability, increased impermeability, drain shrinkage reduction, all other properties, many other properties, higher amount of durability, overall durability is achieved but when you are using OPC PFA mixes. So in such a case, you cannot be in a hurry to de-shutter immediately. You need to give some time for the concrete to set, and there may be sometimes a retardation problem also. We have the habit of getting panicky actually. There is nothing to be panic about a small retardation which occurs actually. If your concrete is setting in 12 hours, let us say the concrete is setting in 18 hours or 20 hours, it doesn't matter actually. It doesn't matter. Only, okay, probably you cannot raise your columns, or you cannot walk over or dance on the slab, something like that. But the concrete is there, it will set actually. We need to exhibit that amount of patience. That is a minimum requirement when you are gaining so many benefits with fly ash. So we should not expect the concrete to set normally. There is a slight delay in setting time, and we should understand that for the other benefits that the fly ash concrete gives, we should be ready to expect small delays in setting time. And most importantly, not but the least, any SMX, especially the concrete with fly ash, needs good curing actually. Good curing, both in the initial stages. If you need to control the rate of evaporation of water from the surface, and you need to protect the concrete either by plastic sheets or making the bunds quickly on the morning, next day morning itself, and to put natural water available. Or you can go like 20 years back I mentioned this KOLLAM software park. So all the concretes, whenever it was finished, initial stages, concrete was sprayed with pesticide sprayer, and then any cracks found because the temperature in Chennai was very high, is very high, and quick evaporations led to some cracks. So the cracks were retamped, revibrated, and then over this, the customer applied, asked the contractor to apply a curing compound. After curing compound was applied, also a plastic sheet was put, and then on the plastic sheet, he was putting a lot of amount of water to keep the entire concrete slab cool in a hot climate like Chennai actually. So we need to have continuous curing and extended curing periods because we are taking advantage. We want to tell you very clearly that the advantages of OPC plus fly ash mixes are really remarkable, and we cannot have that kind of durability and that much of durability by using plain OPC mixes actually. So plain OPC mixes are nowhere when compared to OPC plus fly ash mixes, especially if you are comparing on chloride ion resistance, sulfate ion resistance, and things like that. So the overall durability is pushed to next level when you are using OPC plus fly ash concrete, and hence to get that benefit, we need to invest on curing actually. We need to extend the amount of curing, the time of curing, and take care of the concrete in the initial stages actually. Fly ash also can be used in manufacturing fly ash bricks, paver blocks. Again, in paver blocks also, some people want to, they want to ship the blocks outside the plant, sell the blocks quickly. So they may have to incorporate accelerators, precast concrete products, structural concrete, as we have discussed for a long time now, cementitious fills. So controlled low strength materials, CLSM, is one of the products that we can that we are talking about, where cementitious fill, low grade cementitious fill, OPC plus fly ash is used actually. Embankment construction it is used, rose-based material it is used, and there are several other applications. Flyash also has applications in agriculture. It has also there is a product called Spheres, which is micro products from Flyash. It has its own applications, and you can manufacture aggregates, lightweight aggregates by using Flyash. So these are some of the applications of Flyash, but we are concerned as concrete technology is more to direct concrete, what it does in direct concrete, and we have seen the benefits of Flyash in using in medium amounts and high volume Flyash concretes also. So from QCrete Readymix concrete, I am signing off. I thank all of you for coming and listening to this lecture on this Saturday. And you have my email ID here. You can write to me any questions. And right now, if you have any questions, probably we can discuss, or you can write to me on this email ID. We'll get back to you as early as possible. I thank once again our MD Shelly Fernandez for encouraging me to speak on this subject, and we'll be putting more efforts to make such webinars more successful. Thanks for your time. You can send questions, or you can talk to me now. Actually, any of the questions can be taken now. Aishwarya.
Hello. Yes, sir.
Aishwarya.
Yes, sir.
Any questions are there? You can ask the audience to ask me actually.
Sir, many of them have written the question.
Okay, can you? We'll just see. Mr. Sharad is asking any other state example like Gujarat where Flyash has been used. Mr. Sharad, Flyash has been used in most of the states actually. Most of the states, many of the states, wherever the thermal power plant is there. Any thermal power plant is there in any state, nearby area, Flyash is being used actually. So it is the availability of Flyash. So most of the states in India, they have these thermal power stations, and nearby cement companies are using, nearby Readymix companies are using, black manufacturers are using. What is the limit of Flyash in concrete? As per IS standards, it is 15% to 35%. But there are enough examples as we discussed here on high volume Flyash concretes. And if the structural engineer agrees, we can move up to different applications, 50-55% based on the applications, different applications and requirements. And it is the ultimately the charge the customer and the specifier. But as far as Indian standards are concerned, the normal structural concrete, in normal structural grade concrete, 15 to 35% is what is the that is the limit as per Indian standards actually. Can we use as a filler material? Yes, we can use it as a filler material. One example I showed actually, say for example, you can use as replacement of sand, maybe 10%, 20%, 30% actually, whatever it is, you can use it actually as a replacement of as a replacement for sand actually. We need to be aware of the fact that as we are using some amount of fly ash as a filler materials, the strength of the concrete will be reducing actually. So because some amount of concrete is used, already fly ash is incorporated, then some more we are incorporating as a replacement for sand, the strength will definitely reduce. We need to understand that we can use the situation to reduce the water cement ratio and then give a higher grade of concrete. So there is no limit as such actually. Some examples are there for where people have used up to 70 or 80% for low strength materials. So you can use as you want actually, as you want based on your applications. Okay, and you need to consult the structural engineer because some of the things as we discussed actually, 28-day strength, as we are increasing the fly ash content, 28-day strength will not be as good as OPC mixes or normal mixes actually. So if somebody is able to wait, for longer durations, then they can increase the fly ash content actually. Some in our projects fly ash source is same, but when it comes to taken trial slump issue, yeah. See, the problem as we have already discussed actually. See, the fly ash which you take for trial, and after 2 months you are taking fly ash. Okay, this may be from a different coal and different transporter, different grade of fly ash itself. So totally characteristics might have changed actually. That is the reason we tell that every fly ash when bulk or when it comes, our sample has to be tested for fineness and other properties actually. Most importantly is the fineness actually. So if we don't take care of this one, then definitely there will be we will be seeing a lot of inconsistencies. Definitely there are inconsistencies. We need to learn to manage the inconsistencies because it is not. It is you can say neither the thermal plant power plant guarantees you anything if somebody is bringing you fly ash, nor the transporter is guaranteeing you anything. So it is not a guaranteed product actually. So it comes as it is picked up from a thermal power plant. So it is your responsibility to take care of the inconsistencies. So that is how it goes actually. You need to manage the inconsistencies, do the concrete, understanding the inconsistencies. The QAQC quality control has to be of highest standard. So how can we reduce the ultimate strength setting time of fly ash concrete? So I don't know what is the meaning of this question actually. Actually, we need to increase the ultimate strength of concrete actually. Ultimate strength of concrete will be automatically increased when you're using OPC plus fly ash mix with a reasonable water cement ratio, reduction in water cement ratio. Setting time of concrete using fly ash is generally higher when compared to normal OPC mix concrete actually. So it gives allowance to a Readymix concrete producer to transport the concrete, place the concrete, and finish the concrete for longer time. But if you want to reduce the setting time, means you want to accelerate, you need to use different admixtures, accelerators to reduce the setting time of concrete actually. So ultimate strength will be improved when we are talking about when we are using fly ash actually. type of fly ash available? Anaga is asking. Mostly type of fly ash available in India is maximum available is class F fly ash, and class C fly ash, which is having a CaO content of more than 10%, is available only in some plants actually. And there is Lignite Corporation of India, where is lignite, where the fly ash is comes under class C, is having a very high amount of fly ash and high amount of sulfates, and generally not preferred by concrete industries actually. But if it is ground and can be used for other purposes actually. So the type of fly ash which is predominantly available in India is class F fly ash available. So thank you very much. Any other questions? I can take it. I can answer to you by mail. Actually, you can also visit our Dr. Q section in QCrete Readymix website actually, or you can send me my mail, or you can send me through a mail to me actually. Thanks a lot once again. Thank you very much.